So shall we start now? So far we have seen that what is a vector, a scalar quantity, what is vector quantity, what is tensor quantity, and we have understand that if the only magnitude is required to define the physical quantity, so this is known as the scalar, and also it is known as the first order, zeroth order tensor. When in order to define a physical quantity, if we require the magnitude as well as the one direction, then it is a vector quantity, and also it is known as the first order tensor. If we require to define any physical quantity, magnitude and the two direction, then it is known as dyadic or second order tensor. Stress and strain are the example of second order tensor. It is very easy to understand that stress is second order tensor, but really strain is also a second order tensor. That we will see all these things, that how do we know that whether it is second order tensor or not. Even this, how stress is second order tensor, what is the physical significance of this, we will see in the later part of this course. Now after that we have studied that what is the meaning of the vector, what are the various concept of vector algebra, and we have learned the cross scalar product of two vector, vector product of two vector, scalar triple product, vector triple product, plane area as a vector, and their geometrical representation and geometrical and physical meaning, so that we can understand the vector. Also linear dependency, linear independency, all these concept we have learned in the first part of this class. Now very important question, if you try to understand, then so we have discussed the vector A, we have discussed many concept of the vector, but still we have not used any coordinate system, isn't it? So can we say this vector quantity is independent of coordinate system or invariant of coordinate system?
Yes, because its magnitude preserves.
Even direction also preserves.
Okay.
The direction will not change. So the quantity, vector quantity, it does not depend on coordinate system, because all discussion what we have discussed so far, that we have not even discussed about the coordinate system. What we from our 12th standard we are habitual to decompose the vector in x, y, z coordinate system, and then doing all these mathematics and addition, subtraction, multiplication, and so on. But we have discussed multiplication, we have discussed addition, we have discussed the multiplication of three vector and so on, but without using coordinate system. So now why this coordinate system is important? The one question. First important concept is all the physical quantity is not depend on actually coordinate system. Rather, when we are considering some coordinate system, then with respect to those coordinate system, their component, the magnitude of component will you will get that, okay, the component in x direction is this, component in y direction is this, and so on. Finally, the resultant of this should be independent of coordinate system. If we will rotate the coordinate system, we will get the same physical quantity. Their meaning is not going to change. So what is this coordinate system and why it is important? Okay, before going to this coordinate system, let me discuss the process, that what actually we are doing, because we are observing something. Okay, so let's say there is an object, and that object is some physical quantity before us. It may be force, it may be displacement, it may be velocity, we are observing, and this object itself is not defined. We need an observer also who is observing this process, isn't it? So there is an observer who is observing an object, and that object here for us is a physical quantity. Okay, so this three together completing the whole phenomena, whatever we are observing. Now, actually what we are doing here, we are fixing a coordinate system when we are saying that, okay, this is what coordinate system is. Let's say this is your well-known x, y, and z coordinate system, and this is what, let's say, origin of this coordinate system. Actually, we are giving a position to observer. This is what the observer is here, and with respect to this coordinate system, this observer is observing something, either force or velocity, and or these different type of physical quantity. Even as a observer, we are observing whole universe, isn't it? So this process, observer, object, and process of observing is going on in order to study something. So actually we are giving a location, we are fixing the location of an observer in a space, and for that purpose we require coordinate system. And that is why it is important that if we are changing the position or location of observer, the physical phenomena will not change. So our observation should be independent of location of observer. So it means it should be independent of coordinate system. So it means it is invariant of coordinate system. So even all natural law, all physical quantity, what we are referring for, that must be independent of location of observer. If I am observing from here, someone is observing from another place of this universe, then the physical phenomena will not get changed. So this is what the concept. So now when we are fixing the position of observer, we require a coordinate system. Okay, this is the philosophical concept of observer, object, and process of observing. Now, our well-known coordinate system we have studied from our childhood, and I'm not going to change for now it. This is x, y, and z, and this is what origin, and unit vector along x is I, unit vector along y is j, and this is k. This is also well known to us. And since these x, y, z are linearly independent, it is forming the independent base vector. So that's why this I, j, k are the base vector, are the base vector to define this coordinate system. And in geometrical space, our three-dimensional, we are following this three-dimensional, we are saying the three-dimensional space because this three independent, linearly independent bases are formed in order to define it. That's why we are saying this, our geometrical space is three-dimensional, and so on. This is the reason. So we have this I, j, k are the base vectors, and if it is linearly perpendicular, and also it is perpendicular to each other. So if this is so, then this I dot I j dot j k dot k is equal to 1. And if you are doing the dot product of two different base vector I dot k j dot k, then it must be 0, and this is satisfying the perpendicular condition. We know all these things, we are familiar with this. And after this, if there is a some vector in xyz plane, the three-dimensional space, if there is a some vector, let's say for example f, then we can write this as f is equal to f1, or sorry, fx I plus fyj plus fjk. So we can decompose this in three vector where fx, fy, fz are the components of vector f along x, y, and z axis, and these are the scalar quantity. It is showing the only magnitude. So this is what you are having in this plane, and so on. So this is fy, this is what you have fx, and this is what you have fj. And you can write this vector like this using the base vector of this three-dimensional space. So you all are familiar with this. I'm going to change a notation because for further use, instead of ijk, I will follow, let's say we have this axis is x1, instead of xyz, can we say that x1, x2 and x3? Only thing, we have to follow a clockwise order, anti-clockwise order, that is positive as per convention. So x1, x2, x3. Okay, and the base vector of this is e1 cap, e2 cap and e3 cap. So now our coordinate system is, we are following O, x1, x2 and x3, where we have kept our observer, and from here this observer is observing an event. Okay, now the E1, as we have ijk, we are here having E1, E2 and E3 are the base vector, okay, of this coordinate system. Now if this is so, let's say we are having some the vector b, and before that it must satisfy this condition also, e1 cap, e2 cap, e2 cap plus e3 is equal to 1, and with dot product with other base vector should be equal to 0 in order to maintain the condition of perpendicularity. E2, E3 is equal to 0. Now here we have represented a vector v, and this v can be written as, vector v is v1 e1 cap plus v2 e2 cap plus v3 e3 cap. Again here, this v1, v2, v3 are a scalar quantity. e1, e2, e3 are the vector quantity. So these are the base vector. Okay, and yeah, so these are the base vector. And now can we write this as with summation sign, I is equal to 1 to 3 vi ei. We can write this. When we are writing this summation sign, then we understand that actually this is the short form, and expanded form will be v1 e1 plus v2 e2 plus v3 e3 of meaning, which is the meaning of this summation sign. Okay, now I do not want to carry this summation sign, right? If we do not want to carry, then can we write this as vi ei cap, but we know that this is equal to this. So when we are doing this, this is known as summation convention. And it was proposed by Einstein, so it is also known as Einstein's summation convention. For simplifying the equation, not writing at this all the summation sign, they have just simply removed this, and this, when we are writing this v1 e1 v2 e2 plus v3 e3, as simply vi ei, keeping the point that I varies from 1 to 3 if it is a geometrical, three-dimensional geometrical space, then this is known as summation convention. Here, what is the important thing to be noticed? We have used the I subscript. I subscript. And this subscript comes twice in this expression. When and instead of VIEI, if I am writing VJ, EJ, will it going to make any difference? No, it is not going to make any difference. It will again have the simply I and J must vary from 1, 2, and 3 simply. So both will have the same meaning. So actually it is kind of a dummy subscript. So either we use I, J, K, L, M, N, it is not going to make any difference. But only thing is, in the expression, it comes twice. Whenever in an expression, any indices or subscript coming twice, then it means that we have to do summation over that subscript. Okay, so this is what the summation convention. And more than twice, if let's say you are having expression vi ui ei, it is having no physical meaning, no meaning. So this is wrong. More than twice, not possible. Have no significance, no meaning. Of more than twice, not possible. But in a subscript, in an expression, you may have ui v ui vi wj gamma j and so on. So here if you see this, the dummy index or the summed, it is also known as summed subscript, summed indices, because we are doing the summation over this subscript or in this index, so we can also term as summed index. So we can use the two here I and J, two summed index or dummy index have been used, but we cannot use UI, VI and EI. The thrice is not possible. More than twice is not possible because it is not having any physical meaning, physical significance. That is the reason. Okay, so this is about the summation convention and how we will use all these things, because this will make our equation very simple. Even the very complex mathematical calculation, what we are doing in the vector or tensor, that can be made easy and very simple when we are using these indices with the concept of summation conventions. And there is a free index concept also that we will discuss in the next class. So, and you will see in the next classes, you will see that how this all the multiplication, addition, and a various operation, vector algebra operation or vector calculus operation, tensor calculus operation, field calculation can be done in a very easy way if by using this indices concept. But we have to be very careful that if you will do a mistake, like the mistake as I told you that UI, VI, and EI is not correct. If you are doing anywhere the mistake with the indices, then whole expression will be wrong. So we have to learn these concepts very in a medium pace way, and also all these concepts should go with inside to our system so that we can use it in a proper way. So next class I will discuss more on these things, mostly on the index property and some example. We will solve some example, then we will do some mathematical operation on the vector, and to get more confidence to use this concept. Okay, so I'm stopping today's lecture here. If you have any question, then I want to take those questions, want to clarify your doubt, and then we will stop. Okay, please, question please. Diptanshu Pal.
Yes.
Yeah,
Yeah.
you have.
So actually, these concepts I had a preliminary. I mean, course. So these concepts
Okay,
are kind of
already you know.
fine. So
Okay,
yeah, I mean, most of them. So
okay.
I mean, what I can ask is UI, VI, and WJ, gamma J as you have written.
Haha. Yes, yes,
So
yes.
how many terms will appear there? Let's say it's a three-dimensional space.
There will be nine.
So
There will be
nine
nine.
terms. So for UI, VI, there will be summed up. Three terms will be summed
Yes,
up, and
and
for
three.
each of those three,
Yeah,
WJ and gamma J will be summed up.
WJ. Yes, yes.
Okay.
So
So
if
we
they
can
are,
have
they
yes.
are, let's say n is the number of. Let's say there are two here. If you see, there are two dummy indexes or the summed indices. So then 3 multiplied by 2. So I 1 2 3 j. So there will be actually 9 terms in this expression. In next class, I will discuss all these things also. We
So
will have.
one other question is, can there be the different number of summing terms? I mean, let's say I can take three, 1, 2, 3, and J can take 1, 2. Can that be possible? Or if
No, that
this
that
is
is not possible. That is not possible. It
okay,
should.
so in one expression there has to be one
Yes.
three-dimensional space, and then there will be three for all the indexes.
Yes.
That's
See
okay.
why it is not possible. If you are putting your observer in three-dimensional space,
Okay.
then whole phenomena he is observing in three-dimensional space. Even it thinks even the event is happening in a plane, but third direction is there. For him, third direction is there. That will, let's say, the zero that will have the zero component. Magnitude may not have in that direction.
So the
But
original
still,
expression will be three, but
yeah,
one term may go to zero after the
yes,
event has.
yes, that should be consistent. Yes,
Okay.
yeah. Any other question?
In case of relation between stress and strain,
Yeah.
uh, do we have? You said that it is fourth order tensor we get, so it has,
Okay. Yeah.
I think, 81 components because
Yes, there will
9
be
into
81
9
concept. So
permutations will be
when you
there.
are relating, let's say, your simplest constitutive relationship,
Yes.
this is having 9 component. Further, following the law of symmetricity, it will have 36. Sorry, 6. This is again having 9 component. So you are correlating the 9 component of a stress with 9 component of a strain. So it must have 81 component.
Okay.
In index notation, it is represented at sigma ij is equal to, if this is KL, then
I J J
EIJ
K L.
KL. So there
Okay.
are 4 indices, so it will have 81 component.
So it is
3 raised to
contracting
4.
between K and L.
Yes.
E.
Finally,
Okay.
when because of symmetricity, it will reach to the 6th component. It will again have the 6th component because tau xy is equal to tau yx. Then it will reduce to 36 component. Further,
Okay.
you
Okay.
will impose some condition. Then it is reducing for isotropic condition, where the it will become
3 and 3.
only 2 are required to define this,
Okay.
isn't it? Okay. Any other question?
Yes, sir.
Yeah, Dravid.
My question is about the invariance of vectors. So,
Yes,
how can we prove that mathematically? This thing.
you try it and tell me how to prove it. I have given you that
Okay.
simply see, will force vector, if some force is applying on some object, if by
Yeah.
changing the location of observer, will this force get changed?
No.
Component of this force depend on coordinate system.
Yes.
Force does not depend, but finally the resultant magnitude you will apply and determine, or direction in which it is acting, that
Yeah.
will be, that
Yeah.
not going to change with the location of the
Mm.
coordinate system. That's why it is called as the physical quantities are independent of the coordinate system.
Yes,
And
sir.
that is whatever independent of coordinate system, that is invariance law is called. And also then in mechanics and in all the natural phenomena, this is very important to prove this. that whatever we are writing, whether it is invariant to the coordinate system or location of observer or not, isn't it?
Yes, sir.
Okay.
Yeah. Okay.
So, any more question? If not, then shall I stop and we will meet tomorrow?
Yes, sir. Tomorrow.
Okay. Thank you. Thank you very much.
Thank
Have
you,
a
sir.